Have you ever noticed how some places on Earth feel almost impossible, as if they shouldn't exist at all? In this episode of Unearthed Secrets, we explore the mirror at the end of the world, the hole that drinks the ocean, deserts that fill with water, and landscapes shaped by heat and time. Before we begin, like and subscribe, and tell us in the comments where you're watching from and what time it is for you right now. The mirror at the end of the world. High on the Andean, Altiplano of southwestern Bolivia lies a surface so vast and uniform that it bends perception itself. At certain times of year, the sky does not end at the horizon. It continues downward, reflected perfectly beneath one's feet, erasing the line between above and below. This is Salar de Uyuni, the largest salt flat on Earth, a place where water, salt, and light combine to create one of the planet's most extreme and disorienting landscapes. Salar de Uyuni spans more than 10,000 square kilometers, sitting at an elevation of approximately 3,656 meters above sea level. From space, it appears as a bright white scar across the plateau. On the ground, it feels endless. There are no trees, no roads in the conventional sense, and almost no elevation change. The land stretches outward in every direction with such consistency that distance becomes difficult to judge. Objects appear closer than they are. Movement feels slower than expected. The landscape offers no visual reference points, only scale. The salt flat occupies the basin of a prehistoric lake system that once covered much of the Altiplano. Tens of thousands of years ago, this region was home to massive bodies of water, including Lake Minchin and later Lake Tauca. As the climate shifted and the lakes gradually evaporated, they left behind thick crusts of salt and mineral-rich sediments. What remains today is a layered record of ancient water locked into solid form. Beneath the surface crust lies brine saturated with lithium, potassium, and other minerals. This subterranean layer makes Salar de Uyuni not only a geological phenomenon, but also one of the world's most important sources of lithium, a key component in modern batteries. Yet despite its economic significance, the surface remains strikingly simple. A flat expanse of salt, arranged in natural hexagonal patterns, formed as brine evaporates and contracts. During the dry season, typically from May to October, the salt flat is a hard, blinding, white plain. The surface fractures into polygonal tiles, each outlined by narrow ridges of salt. Walking across it produces a distinct crunch underfoot, and the air feels thin and sharp at altitude. The sun reflects intensely off the white ground, making sunglasses essential. Shadows appear unusually crisp, and the sky seems deeper blue than elsewhere. During the wet season, usually from December to March, a thin layer of water, often only a few centimeters deep, spreads across the flat. When conditions are calm, this water transforms Salar de Uyuni into the world's largest natural mirror. The salt crust beneath is so level that it reflects the sky with extraordinary precision. Clouds, sun, and stars appear duplicated below, creating the illusion of walking through the sky itself. This mirror effect is not merely aesthetic. It has scientific applications. Satellite agencies have used Salar de Uyuni to calibrate Earth-observing instruments because of its extreme flatness and reflectivity. Few places on Earth provide such a stable, uniform surface over such a vast area. The flatness is remarkable. Variations in elevation across kilometers measure only a few centimeters. This precision is the result of slow, repeated cycles of flooding and evaporation that redistribute salt evenly across the basin. Over geological time, these cycles have erased irregularities, producing a surface closer to level than most man-made structures. Despite its apparent emptiness, Salar de Uyuni is not lifeless. Microbial communities exist within the brine beneath the crust. During the wet season, flamingos arrive in large numbers to feed on algae in nearby saline lakes. 3 species, Andean, Chilean, and James's flamingos, use the region as part of their breeding cycle. Against the white salt, their pink bodies appear almost unreal. Scattered across the salt flat are islands that rise abruptly from the white surface. The most famous is Inkawasi, a rocky outcrop covered in giant cacti that can grow more than 10 meters tall. These islands are remnants of ancient volcanic formations, once submerged beneath the prehistoric lakes. Today, they serve as rare points of vertical relief, breaking the horizon and offering a sense of scale. For centuries, indigenous communities have lived around the edges of the salt flat. The Aymara people, in particular, have long understood the rhythms of the Altiplano. Salt harvesting has been practiced here for generations. Blocks of salt are cut from the crust by hand, dried, and transported to nearby towns. This activity continues today, though it is small in scale compared to industrial extraction elsewhere. The salt flat also holds cultural meaning. In local belief systems, the landscape is tied to ancient stories of mountains, spirits, and loss. One legend speaks of a giant who wept tears that became the salt flat, a narrative that frames the vastness not as emptiness, but as the residue of emotion and time. Modern access to Salar de Uyuni is typically through the nearby town of Uyuni, a former railway hub that once connected Bolivia's mineral-rich interior to the coast. Today, Uyuni serves as a staging point for expeditions across the salt flat. Vehicles must be specially prepared. Navigation relies on GPS rather than landmarks. During the wet season, routes change daily depending on water depth and surface conditions. Driving across Salar de Uyuni can feel surreal. The horizon remains fixed, no matter how long one travels. Speed becomes difficult to judge without roadside references. In the mirror season, the boundary between water and sky disappears entirely, and the vehicle appears to float through space. Even experienced drivers proceed cautiously, as hidden variations in crust thickness can pose risks. At night, the salt flat takes on a different character. Far from city lights, the sky above the Altiplano is exceptionally clear. When the surface is dry, the white salt reflects moonlight, softly illuminating the ground. When wet, the stars are reflected below, creating the illusion of infinite depth in both directions. The Milky Way appears doubled, suspended above and beneath the viewer. Weather on the salt flat can change rapidly. Sudden storms bring lightning that travels unobstructed across the open plain. Winds can rise quickly, breaking the mirror effect and turning the surface into rippling silver. Temperatures drop sharply after sunset, and the thin air amplifies the cold. Despite its apparent stability, Salar de Uyuni is a dynamic system. Seasonal flooding dissolves and redistributes salt. Wind sculpts the surface subtly over time. Beneath the crust, brine slowly shifts, responding to pressure changes and extraction activity. The flat may appear frozen, but it is constantly in motion at scales difficult to perceive. The presence of lithium beneath the salt has brought new attention and new tension. Bolivia holds some of the world's largest lithium reserves, and Salar de Uyuni is central to national plans for resource development. Extracting lithium from brine requires pumping and evaporation, processes that must be managed carefully in such a fragile environment. Concerns remain about water use, ecological impact, and long-term changes to the salt flat structure. Balancing economic opportunity with environmental preservation is an ongoing challenge. For now, much of Salar de Uyuni remains visually unchanged, but the future of the flat is tied increasingly to global demand for energy storage technologies. For visitors, the experience of Salar de Uyuni often defies expectation. It is not dramatic in the way mountains or waterfalls are. There's no single viewpoint that captures it. Its impact comes from duration and exposure, standing within it long enough for scale to register, for silence to become noticeable, for the mind to adjust to the absence of reference. Sound behaves differently here. With little to absorb it, noises carry far. Wind becomes the dominant presence. Footsteps echo faintly. In the wet season, the shallow water muffles sound further, creating an unusual quiet that feels expansive rather than empty. Photography on the salt flat is famously deceptive. Forced perspective images are easy to create because distance is so hard to judge. People appear miniature or colossal depending on positioning. While playful, these distortions reflect a deeper truth. Salar de Uyuni disrupts normal spatial cues. It challenges how the human brain interprets distance, scale, and orientation. Scientifically, the salt flat continues to be studied for what it reveals about evaporation basins, mineral cycles, and climate history. Layers within the crust preserve chemical records of past rainfall and temperature patterns. By drilling cores, researchers can reconstruct environmental changes spanning tens of thousands of years. Those same records also make Salar de Uyuni a planetary analog. Scientists studying Mars and other planetary bodies look to salt flats like this to understand how minerals form in arid environments and how ancient water systems might leave detectable traces. Yet for all its scientific and economic importance, Salar de Uyuni remains, at its core, a place defined by simplicity. Salt, water, sky, the repetition of white, the absence of obstacles. the slow rhythm of seasonal change. There are moments on the flat when the sense of time loosens. Without shadows or landmarks, hours can pass unnoticed. The environment offers few cues for urgency. It is easy to feel detached from schedules and distances measured elsewhere. As the sun lowers, the white surface shifts in tone from brilliant to soft pink, then pale blue. When the light fades completely, the flat becomes a dark, open plain beneath the stars. The day's reflections vanish, replaced by depth and silence. Salar de Uyuni does not overwhelm through force. It does not threaten. It simply removes boundaries. In doing so, it exposes how much of human perception depends on contrast, edges, and reference points. When those disappear, the world feels larger, quieter, and less certain. Long after the ancient lakes vanished, the salt remains. Long after vehicles cross its surface and satellites map its reflectivity, the cycles continue. Flood, evaporate, settle, repeat. At the center of the Bolivian Altiplano, the land remembers water by becoming a mirror, and in that reflection, the earth reveals a version of itself that feels both ancient and strangely unfinished, flat, bright, and waiting for the sky to return. The hole that drinks the ocean. On the central Oregon coast, where basalt cliffs meet the restless Pacific, there's a place where the sea appears to vanish into the earth itself. Waves rush toward the shore, surge across dark volcanic rock, and then pour downward into a circular opening as if the ocean has found a drain. Moments later, water erupts back upward, spraying foam and mist into the air before retreating again. This is Thor's Well, a coastal feature that has earned a reputation as one of the most unsettling and misunderstood formations in North America. Thor's Well is located at Cape Perpetua, along the rugged shoreline of Oregon, a region shaped by ancient lava flows, relentless wave erosion, and tectonic movement. The well sits just offshore, carved into basalt rock, and is accessible only during low tide and calm conditions. At first glance, it appears to be a bottomless pit, an opening that swallows seawater without filling. The illusion is powerful enough that many visitors assume it must descend deep into the earth. In reality, the explanation is both less mysterious and more revealing about the forces shaping the coastline. Thor's Well is not a true hole leading downward into subterranean caverns. It is the collapsed remains of a sea cave, formed by the steady erosion of basalt by wave action. Over thousands of years, the Pacific Ocean exploited fractures in the volcanic rock, hollowing out chambers beneath the surface. Eventually, the roof of one such cave collapsed, leaving behind a vertical opening connected directly to the ocean. The result is a structure that behaves like a drain, only because of timing and geometry. When waves surge in during high tide, water is forced into the cave system below and pushed upward through the opening. When the wave retreats, gravity pulls the water back down, creating the appearance that the sea is being swallowed whole. The well never fills because it is open on multiple sides, constantly exchanging water with the ocean. The basalt that forms Thor's Well is part of the Columbia River Basalt Group, one of the largest volcanic events in Earth's history. Around 15 to 17 million years ago, massive lava flows covered much of what is now the Pacific Northwest. These flows cooled into layered basalt, hard yet fractured, providing the raw material for Oregon's dramatic coastline. Over time, tectonic uplift raised portions of the coastline while wave erosion carved it away. The Pacific here is especially powerful. Winter storms generate waves that can exceed 20 meters in height offshore, carrying immense energy toward land. Each impact sends pressure into cracks and seams in the rock, slowly widening them. Saltwater intrusion, hydraulic pressure, and mechanical abrasion work together, grain by grain, year after year. Sea caves are common along this coast, though most remain hidden beneath cliffs or partially submerged. Thor's Well is unusual because its roof collapsed cleanly, leaving a nearly circular opening visible from above. Its symmetry enhances the impression of intentional design, though it is entirely the result of natural erosion. The name Thor's Well is relatively recent and unofficial. It does not originate from indigenous traditions or early European exploration. Instead, it reflects a tendency to assign mythological explanations to features that feel violent or unnatural. The idea of a Norse god associated with thunder and power fits the drama of water crashing into stone. However, there is no historical evidence linking the name to any ancient belief system. Earlier names included the Spouting Horn, referencing the way water erupts upward during heavy wave action. Even today, that behavior is what draws photographers and visitors, particularly during storms and high tides when the effect is most dramatic. The danger of Thor's Well is often underestimated. Despite its popularity, it is one of the most hazardous locations on the Oregon coast. The same forces that make it visually compelling also make it unpredictable. Rogue waves, larger than expected waves that arrive without warning, can sweep across the rock platform, pulling people toward the opening or knocking them into the ocean. The basalt around the well is uneven and slick with algae. Even during calm conditions, footing is unstable. Several rescues and injuries have occurred here, and fatalities have been narrowly avoided. Local authorities and experienced guides consistently warn visitors to keep a safe distance, especially during high tide or stormy weather. Ironically, the safest time to view Thor's Well is during low tide, when wave energy is reduced and the water movement is less violent. During these periods, the well appears calmer, though it still drains and refills rhythmically. At extreme low tide, parts of the underlying cave system can be glimpsed through side openings, revealing that the whole is part of a broader network of hollowed rock. Despite its dangers, Thor's Well has become a symbol of the Oregon coast's raw character. Unlike sandy beaches designed for recreation, this shoreline is confrontational. It does not invite casual interaction. It demands attention, respect, and distance. The surrounding area of Cape Perpetua is itself geologically significant. The headland rises more than 240 meters above sea level, making it one of the highest points accessible by vehicle on the Oregon coast. From above, visitors can observe the collision between land and sea on a grand scale. Waves breaking against cliffs, whitewater spreading across rock shelves, and currents swirling unpredictably below. The name Cape Perpetua was given by Captain James Cook in 1778. He observed the cape on March 7th and named it after St. Perpetua, whose feast day fell on that date. Cook did not land here, but his naming marked one of the earliest European records of the area. Long before European contact, indigenous peoples lived along the Oregon coast for thousands of years. Tribes such as the Alsea and Siuslaw depended on marine resources, harvesting fish, shellfish, and sea mammals. While there's no specific legend tied directly to Thor's Well in recorded indigenous oral history, the coastline itself held deep cultural and practical significance. To those communities, the ocean was neither a spectacle nor a threat alone. It was a provider and a force to be understood through experience. Dangerous areas were recognized and respected. The modern fascination with standing close to violent water contrasts sharply with the older survival-based relationships to the coast. Scientifically, Thor's Well offers insight into coastal erosion processes. Sea cave formation depends on rock type, wave energy, and structural weaknesses. Basalt is relatively resistant compared to softer sedimentary rocks, which is why features like Thor's Well are less common. When they do form, they highlight how even hard volcanic rock yields to persistent force. The well's continued existence is not guaranteed. Erosion is ongoing. The opening may widen, edges may collapse, or the internal cave may change shape. Over geological time, Thor's Well could evolve into a broader blowhole, collapse entirely, or become less distinct as surrounding rock erodes at similar rates. Blowholes are another related coastal feature often confused with Thor's Well. A blowhole forms when a sea cave develops a vertical shaft to the surface, allowing water and air to be forced upward under pressure. Thor's Well behaves somewhat like an inverted blowhole, drawing water downward instead of expelling it exclusively upward. In reality, it does both, depending on wave timing. During storms, the distinction disappears. Water explodes upward, outward, and downward simultaneously. Spray can reach several meters into the air. The sound becomes overwhelming, a continuous roar punctuated by sharp impacts. The ground vibrates faintly underfoot, a reminder that the energy involved is immense. The Pacific Ocean off Oregon is cold year-round, with temperatures rarely exceeding 12 degrees Celsius. Combined with strong currents and rocky terrain, this makes accidental immersion extremely dangerous. Hypothermia can set in within minutes. Rescue is difficult due to wave action and limited access points. These realities make Thor's Well a place best observed, not approached. Its power lies in motion, not proximity. From a safe distance, patterns emerge. Waves arrive in sets. The well breathes rhythmically, emptying and filling. Foam traces invisible currents. Over time, the chaos reveals structure. Photography has played a major role in shaping Thor's Well's reputation. Long exposure images smooth water into flowing ribbons. exaggerating the illusion of a draining ocean. While visually striking, these images can be misleading. They compress time, hiding the sudden surges that make the sight dangerous. Visitors, encountering Thor's well for the first time, often experience a sense of disbelief. The idea that the ocean could disappear into a hole challenges basic assumptions. That reaction speaks to how rarely humans witness natural processes without filters or barriers. Thor's well strips away comfort and control, leaving only force and repetition. The well also illustrates a broader truth about coastlines. They are not static boundaries. They are zones of exchange, constantly reshaped by energy moving between earth and sea. What appears solid is temporary. What appears empty is connected. At sunset, Thor's well takes on a different character. Light reflects off wet basalt, turning it bronze and gold. The water glows briefly before darkness returns. In low light, the opening becomes harder to see, increasing risk but also heightening the sense of uncertainty. This is not a place that reveals itself easily. At night, the sound remains even when the form disappears. Waves crash, water drains, air moves through unseen chambers. The process continues whether observed or not. Thor's well does not perform. It persists. There is no final explanation that removes its impact. Understanding the geology does not make the site less compelling. If anything, it reinforces how much energy is involved in shaping something so deceptively simple. A hole in the rock, water moving through it, over and over. Thor's well is not a gateway, not a bottomless pit, and not a supernatural force. It is the visible edge of a system that extends beyond sight, beneath the rock, into the sea, and back again. It exists because pressure seeks release, and because stone, no matter how hard, yields given enough time. On the Oregon coast, the ocean does not knock politely. It tests, wears down, and reshapes everything in its path. Thor's well is one result of that process, caught in a moment where destruction and form coexist. It does not drink the ocean. It reminds us that the ocean is never still, never contained, and never finished with the land. And as long as waves continue to arrive from across the Pacific, Thor's well will continue to empty and fill, an opening shaped by patience, powered by motion, and misunderstood by those who stand too close. The desert that fills with water. Along the northeastern coast of Brazil, there's a landscape that defies nearly every rule associated with the deserts. Vast white sand dunes roll outward to the horizon, shaped by wind into soft, repeating ridges. The sun is intense. Vegetation is scarce. At first glance, it looks like an arid wasteland, but scattered between the dunes are pools of clear, blue, and green water, thousands of them, stretching across the sand like fragments of sky fallen to earth. This is Lençóis Maranhenses, a place where a desert floods every year, and life adapts to disappear and return. Lençóis Maranhenses is located in the state of Maranhão, along Brazil's northern Atlantic coast. The protected area covers roughly 1,550 square kilometers and is designated as a national park. Despite being commonly described as a desert, Lençóis Maranhenses does not fit the scientific definition of one. It receives substantial rainfall, far more than most deserts on Earth. What makes it appear desert-like is not lack of rain, but the near-total absence of permanent vegetation and the dominance of sand. The name Lençóis means bed sheets in Portuguese, a reference to the way the dunes resemble white fabric draped across the land. From above, the comparison becomes clear. The dunes form long, smooth folds, separated by shallow basins that fill with water during the rainy season. The result is a landscape that appears meticulously designed, though it is entirely the product of wind, water, and sediment. The origin of Lençóis Maranhenses lies in a delicate balance between river systems, ocean currents, and atmospheric patterns. Sand carried by rivers from Brazil's interior is transported toward the coast and deposited along the shoreline. Strong coastal winds then drive this sand inland, building massive dune fields over thousands of years. Unlike many deserts, however, this region sits beneath seasonal rain systems tied to the movement of the Intertropical Convergence Zone. Each year, typically between January and June, heavy rains fall across the region. Water collects in the low points between dunes, forming freshwater lagoons. These pools can be several meters deep and stretch for hundreds of meters, creating a patchwork of water amid the sand. The dunes themselves act as barriers. trapping the rainwater and preventing it from draining quickly into the sea. The lagoons are temporary. As the dry season sets in, evaporation gradually reduces their size. By late autumn, many disappear entirely, leaving behind dry sand until the next rainy cycle begins. This annual transformation gives Lençóis Maranhenses its defining character, a place that alternates between aridity and abundance. The water in the lagoons is surprisingly clear and clean. The sand beneath acts as a natural filter, and because the water is replenished each year by rain rather than rivers, sediment and pollutants are minimal. Temperatures are warm, making the lagoons inviting for swimming during their brief existence. One of the most remarkable aspects of Lençóis Maranhenses is that life persists despite the seasonal disappearance of water. Several species of fish inhabit the lagoons, appearing shortly after they form. During the dry season, when the lagoons vanish, these fish do not migrate. Instead, they survive by burrowing into the damp sand or mud beneath the lagoon beds, entering a dormant state until the rains return. When the water reappears, the fish emerge as if uninterrupted, resuming their life cycle in pools that did not exist months earlier. This adaptation challenges assumptions about aquatic ecosystems and highlights how life can evolve in environments defined by instability. Birds also take advantage of the seasonal abundance. Migratory species arrive to feed in and around the lagoons, exploiting the temporary wetlands before moving on. Insects breed rapidly. Small mammals and reptiles navigate the shifting terrain, timing their activity to the rhythms of water and heat. For humans, Lençóis Maranhenses was long considered inhospitable. The shifting dunes made permanent settlement difficult, and fresh water was available only seasonally. Small communities did form along the park's edges and near river mouths, where fishing and subsistence farming were possible. These communities developed intimate knowledge of the land cycles, understanding when water would appear and when the dunes would reclaim it. Modern recognition of Lençóis Maranhenses came relatively late. For much of Brazil's history, the region remained remote and sparsely documented. It was only in the late 20th century that scientists and travelers began to draw wider attention to its uniqueness. In 1981, the area was officially designated as a national park, protecting it from development and large-scale exploitation. Even today, access remains limited. There are no paved roads crossing the dunes. Visitors typically enter through nearby towns such as Barreirinhas, using specialized vehicles or guided routes. Movement within the park is regulated to prevent damage to the fragile dune systems. Footprints disappear quickly in the sand, but vehicle tracks can linger, altering wind patterns and erosion. Walking through Lençóis Maranhenses can feel disorienting. The dunes look similar from every angle, and the absence of landmarks makes navigation difficult. The sun reflects intensely off the white sand, amplifying heat and glare. Distances are deceptive. A lagoon that appears close may take far longer to reach than expected. During the rainy season, the contrast between sand and water is at its peak. Lagoons range in color from pale turquoise to deep blue, depending on depth and light. Some are narrow and elongated, others wide and open. Their shapes change subtly as water levels rise and fall. No two seasons produce the exact same pattern. At sunrise and sunset, the dunes cast long shadows that emphasize their contours. The light softens the starkness of midday, revealing subtle textures in the sand. Reflections ripple across the lagoons, mirroring clouds drifting overhead. In these moments, the landscape feels suspended between states, neither fully land nor fully water. From a geological perspective, Lençóis Maranhenses is a study in equilibrium. The dunes migrate slowly under the influence of wind, while the lagoons form and vanish in response to rainfall and evaporation. Remove or alter one element, and the system changes. Reduced rainfall could limit lagoon formation. Changes in river sediment supply could affect dune growth. Shifts in wind patterns could reshape the entire field. Climate change introduces uncertainty to this balance. Variations in precipitation could alter the timing, size, or duration of the lagoons. Sea level rise could influence coastal sediment dynamics, potentially affecting how sand is delivered to the system. Scientists continue to monitor these factors, though long-term outcomes remain unclear. Despite these uncertainties, Lençóis Maranhenses remains one of the most visually striking environments on Earth. Its power does not come from violence or scale alone, but from contradiction. A desert that floods, sand that holds water, life that disappears and returns without leaving. The park's beauty has made it increasingly popular, raising questions about sustainability. Managing tourism while preserving the natural cycles is an ongoing challenge. Strict regulations aim to limit impact, but the draw of the landscape continues to grow. For visitors, the experience often feels unreal. Swimming in a freshwater lagoon while surrounded by dunes creates a sense of displacement, as if the scene belongs to another planet. The knowledge that the water will vanish adds urgency to the moment. Nothing here feels permanent. At night, far from city lights, the dunes cool rapidly. The sky opens wide, stars stretching uninterrupted from horizon to horizon. The lagoons reflect faint starlight when conditions are calm, small mirrors scattered across the sand. The silence is deep, broken only by wind moving across the dunes. Lençóis Maranhenses does not tell a story of endurance through stillness. It tells a story of survival through change. Its defining feature is not what remains, but what returns. Each year, water arrives. Each year, it leaves. And each year, the cycle begins again. There are no ruins here, no monuments built to last. The landscape erases traces quickly. What defines it is repetition rather than memory. The dunes remember the wind. The lagoons remember the rain. Life remembers how to wait. In a world often measured by permanence, Lençóis Maranhenses offers a different lesson. Some places exist precisely because they refuse to stay the same. Their beauty lies in motion, timing, and the brief alignment of conditions. Along Brazil's northern coast, sand and water meet not as enemies, but as partners in a quiet, ongoing negotiation. The result is a desert that fills with water, empties again, and waits, unchanged in spirit, even as its surface is rewritten every year. The hottest place on Earth. In northeastern Ethiopia, at the meeting point of three tectonic plates, lies a region where the Earth seems unfinished. The ground splits, colors bleed from rock, and heat rises relentlessly from below. Temperatures routinely exceed levels considered survivable for much of the year. The air shimmers, the land crackles, bubbles, and exhales gas. This is the Danakil Depression, one of the most extreme environments on the planet, and one of the few places where the raw mechanics of Earth's interior are exposed at the surface. Danakil Depression sits within the Afar Triangle, a geological lowland where the African, Arabian, and Somali tectonic plates are pulling apart. This slow divergence, occurring at a rate of millimeters per year, is tearing the continent from within. Over millions of years, this process may create a new ocean basin. In the present, it has produced a landscape defined by volcanism, hydrothermal activity, salt flats, and chemical pools unlike anywhere else on Earth. The Danakil Depression lies more than 100 meters below sea level in some areas, making it one of the lowest land points on the African continent. It is also one of the hottest. Average daytime temperatures often exceed 40 degrees Celsius, and during heat waves, ground temperatures can soar far higher. Rainfall is minimal and unpredictable. Shade is rare. Water is scarce and often contaminated by minerals. To the unprepared, the region is lethal. To geologists, it is invaluable. The story of the Danakil Depression begins deep beneath the Earth's crust. Here, the lithosphere is thin, stretched by tectonic forces as plates diverge. Magma rises closer to the surface than in most places, heating groundwater and reacting with surrounding rock. Fault lines fracture the land, creating pathways for gases, molten rock, and mineral-rich fluids to escape. This is not a single volcano or geothermal field. It is an entire system, wide, interconnected, and constantly active. One of the most striking areas within the Danakil Depression is the Dalol hydrothermal field. From a distance, it appears like a spill of paint across the desert floor. Yellows, greens, oranges, and whites arranged in unnatural patterns. Up close, the ground is soft and fragile, crusted with salt and sulfur. Pools of acidic water bubble quietly, releasing toxic gases into the air. Dalol exists because groundwater interacts with magma at shallow depths, becoming superheated and chemically altered. As this fluid reaches the surface, it deposits minerals in layers, forming terraces, cones, and delicate crystalline structures. The acidity of some pools rivals that of battery acid. Temperatures fluctuate sharply over short distances. The landscape can change from solid ground to collapsing crust within meters. Despite appearances, Dalol is not volcanic in the traditional sense. There are no explosive eruptions or lava flows here. Instead, the danger is subtle and constant. Toxic. Fumes such as sulfur dioxide and hydrogen sulfide collect in low areas. The ground can give way without warning. Breathing can become difficult. The environment does not announce its threats. Beyond Dalal, the Danakil Depression stretches outward into vast salt flats. These flats are remnants of ancient seas that once flooded the region when tectonic shifts allowed seawater from the Red Sea to enter the basin. As the connection closed and the water evaporated, thick layers of salt were left behind. In some areas, salt deposits are hundreds of meters thick. For thousands of years, these salt flats have been mined by hand. The Afar people who inhabit the region cut salt blocks using simple tools, shaping them into uniform slabs. These slabs are loaded onto camel caravans and transported across the desert, following routes unchanged for centuries. Salt was once so valuable that it functioned as currency in parts of Ethiopia, and the practice continues today, though on a reduced scale. The salt caravans move slowly, often at night to avoid the worst heat. The journey is dangerous. Temperatures can be fatal. Conflict has historically been a risk, yet the trade persists, bound to tradition and necessity. The Afar are among the few groups adapted to life in the Danakil Depression. Their knowledge of the land is practical and inherited. They know where water can be found, when conditions are survivable, and which areas must be avoided. Even so, life here is precarious. The environment offers little margin for error. In contrast to the salt flats and hydrothermal fields, the Danakil Depression also hosts one of the most persistent volcanic features on Earth, Erta Ale. This shield volcano rises above the surrounding plains, its summit crowned by a lava lake that has existed, with brief interruptions, for decades. Lava lakes are rare. They require a constant supply of magma and a stable vent system that allows molten rock to circulate without solidifying or erupting explosively. Erta Ale provides both. The lava lake's surface crust fractures and reforms continuously, glowing orange beneath a darkening sky. Gas escapes in steady plumes. The sound is low and mechanical, like breathing or distant machinery. Erta Ale's name means smoking mountain in the Afar language. For local people, it is a known presence rather than a spectacle. For scientists, it is a rare window into volcanic behavior. The lava lake allows direct observation of magma dynamics, normally hidden deep underground. The volcano is part of a larger rift system, where fissure eruptions periodically release lava across the desert floor. In recent decades, flows have destroyed settlements and forced evacuations. The land here is not stable. It reshapes itself without warning. Taken together, these features make the Danakil Depression one of the most geologically active regions on Earth. It is a place where continental breakup can be observed in real time. The ground is literally pulling apart. New crust is forming even as old crust fractures and sinks. This process is usually hidden beneath oceans, where mid-ocean ridges create new seafloor. In the Danakil Depression, the same mechanism occurs on land. Studying it helps scientists understand how oceans are born and how continents divide. The chemical extremes of the region have also attracted astrobiologists. Some microbial life has been found in parts of the Danakil Depression, surviving in high temperatures, high salinity, and extreme acidity. These organisms are studied as analogs for potential life on other planets, particularly Mars, where similar chemical environments may once have existed. However, not all areas of the Danakil Depression support life. Some pools are so acidic or hot that they are completely sterile. These lifeless zones are equally important scientifically, marking the boundaries beyond which life cannot persist. The visual impact of the Danakil Depression is difficult to convey accurately. Colors are vivid, but not decorative. Yellow sulfur crusts border neon green pools. White salt formations cut through black volcanic rock. Steam rises constantly, distorting the air. The ground crunches underfoot, brittle and sharp. The smell is equally intense. Sulfur dominates, sharp and choking. In some areas, the air burns the throat. Protective equipment is often required for extended study. Even brief exposure can be exhausting. Despite its dangers, the Danakil Depression has drawn increasing attention in recent years. Scientific expeditions, documentary teams, and limited tourism have brought outsiders into the region. Access is tightly controlled, often requiring armed escorts due to past conflicts and the inherent risks of the terrain. Tourism here is not casual. There are no facilities, no signage, and no emergency infrastructure. Visitors must rely on guides who understand the land intimately. Even then, conditions can change rapidly. Heat exhaustion, dehydration, and exposure are constant concerns. For Ethiopia, the Danakil Depression is both a scientific treasure and a logistical challenge. The region's harshness limits development, but its geothermal potential is significant. Harnessing that energy could provide power to surrounding areas, though doing so safely and sustainably remains complex. Culturally, the region sits at the margins of national identity, inhabited by groups whose ways of life predate modern borders. Balancing their traditions with scientific interest and resource potential is an ongoing challenge. At night, the Danakil Depression reveals a different character. Temperatures drop, though not always enough to bring relief. The sky opens wide, stars sharp and unfiltered by humidity or light pollution. Lava lakes glow brighter in the darkness. Steam plumes catch moonlight, turning pale and ghost-like. In these moments, the sense of scale becomes overwhelming. The land feels ancient but also unfinished. It is not eroded into calm forms, nor stabilized by time. It is active, transitional, and exposed. The Danakil Depression does not offer comfort or beauty in conventional terms. Its appeal lies in honesty. Here, the earth doesn't hide its processes beneath forests or oceans. Heat, chemistry, and movement are visible and immediate. It's a reminder that the planet is not static. Continents drift, crust breaks, new land forms, while old land disappears. These processes are usually measured in millions of years, but in places like Danakil, their effects are close enough to feel. For scientists, it is a laboratory without walls. For the FR, it is home, harsh but known. For the rest of the world, it is a glimpse of Earth at its limits. There's no single defining feature that explains the Danakil Depression. It is not one volcano, one crater, or one lake. It is a system, a convergence of extremes driven by forces far below the surface. As long as the plates continue to pull apart, heat will rise, salt will crystallize, and lava will surface. The land will crack and reform. The depression will deepen and widen, slowly preparing the way for something new. In northeastern Ethiopia, the earth is not at rest. It is opening itself, layer by layer, revealing how continents are made, how they break, and how fragile the surface truly is. The Danakil Depression stands as one of the clearest reminders that the ground beneath us is not solid in the way we imagine. It moves, it changes, and in some places it burns openly, exposing the inner workings of a planet still very much alive. The lake that stayed pink. Off the southern coast of Western Australia, separated from the open ocean by a narrow strip of land and a band of dense forest, there's a lake whose color seems deliberately artificial. From the air, it appears bubblegum pink, uniform, opaque, and startlingly vivid. The color doesn't fade at the edges. It does not shift dramatically with light or weather. It simply remains. This is Lake Hillier, one of the most visually perplexing bodies of water on Earth, and a reminder that nature often defies expectation without explanation that feels fully satisfying. Lake Hillier lies on Middle Island, the largest island in the Research Archipelago, a chain of more than 100 islands scattered along Australia's southern coastline. The island itself is uninhabited, protected, and difficult to access. Dense eucalyptus forest covers much of the land, bordered by rugged coastline and white sandy beaches. Lake Hillier sits inland, oval in shape, measuring roughly 600 meters long and about 250 meters wide. What makes the lake remarkable is not its size or isolation, but its color. The pink hue is permanent. It does not disappear in winter. It does not turn blue when disturbed. Even when water is removed from the lake and placed into a container, it retains its pink coloration. This persistence distinguishes Lake Hillier from many other pink lakes around the world, whose colors fluctuate depending on season, salinity, or algal blooms. The lake was first documented by Europeans in 1802, during the British expedition led by Matthew Flinders. While circumnavigating Australia, Flinders anchored near Middle Island and sent a small party ashore. One of the crew members, William Hillier, climbed to a high point on the island and observed the pink lake below. The lake was later named in his honor. At the time, the color was noted but not understood. Early speculation ranged from mineral content to biological staining, but no definitive explanation emerged. More than 2 centuries later, the lake still resists simple answers. Lake Hillier is classified as a saline lake, with salt concentrations higher than seawater. Salt crusts form along its edges, and the surrounding ground shows evidence of evaporation cycles. Yet high salinity alone does not explain the pink coloration. Many salt lakes are white, pale blue, or brownish, depending on mineral composition. Hillier's color is distinctly and consistently pink. The leading scientific explanation involves a combination of microorganisms and chemistry. Researchers believe the color results from the presence of halophilic, or salt-loving microorganisms, particularly certain species of algae and bacteria that produce red and pink pigments. Among the most frequently cited organisms is Dunaliella salina, a type of microalgae known to produce beta-carotene, a red-orange pigment, in high salinity environments. However, Dunaliella salina alone does not fully account for Lake Hillier's uniform color. Similar algae exist in other saline lakes that do not display the same intensity or consistency of pink. Additional microorganisms, including halophilic bacteria that produce reddish pigments, are thought to contribute to the overall hue. These organisms thrive in extreme conditions, high salinity, intense sunlight, and limited competition from other life forms. The pigments they produce help protect them from ultraviolet radiation. Over time, the accumulation of these pigments in the water gives the lake its distinctive color. What complicates the explanation is that Lake Hillier's color appears remarkably stable. Seasonal changes in temperature and rainfall do not dramatically alter its appearance. Even during periods of dilution from rainwater, the pink persists. This suggests a finely balanced system in which biological, chemical, and physical factors reinforce one another. The lake is separated from the Southern Ocean by a narrow sand barrier and a strip of forest. Despite its proximity to the sea, there's no direct surface connection. Seawater does not flow freely into the lake. Instead, salt is believed to accumulate through a combination of groundwater seepage, sea spray, and evaporation over long periods. This isolation may contribute to the lake's unique chemistry. Middle Island itself is part of an ancient geological landscape. The Recherche archipelago formed through a combination of tectonic stability and long-term erosion. Unlike many parts of Australia shaped by dramatic mountain building, this region has remained relatively stable for millions of years. Its rocks are old, weathered, and resistant to rapid change. The island's vegetation reflects this stability. Low forests of eucalyptus and other hardy plants cover much of the land, adapted to thin soils and salty air. Wildlife is limited, but includes birds, reptiles, and insects capable of surviving in isolation. Human impact has been minimal due to the island's protected status and difficult access. Lake Hillier's isolation has preserved it, but it has also limited scientific study. Sampling is restricted to avoid contamination. Large-scale experiments are not possible. Much of what is known comes from small water samples, remote sensing, and comparison with other saline systems. Interestingly, Lake Hillier is not the only pink lake in Australia, and several others exist, including Lake McDonnell and Hutt Lagoon, both in Western Australia. However, these lakes often change color depending on conditions and may shift between pink, red, and purple hues. Hillier's color remains consistently pastel pink, a difference that continues to puzzle researchers. One theory suggests that the lake's shallow depth contributes to its uniform appearance. Light penetrates easily, interacting evenly with pigments throughout the water column. Another proposes that the surrounding sand barrier limits nutrient input, stabilizing the microbial community. Still others point to subtle chemical balances involving salt composition, pH, and trace elements. Despite these hypotheses, no single factor has been identified as the definitive cause. Lake Hillier appears to be the product of multiple reinforcing processes rather than one dominant mechanism. For Indigenous Australians, the islands of the southern coast were part of traditional sea country long before European exploration. While specific recorded stories about Lake Hillier are limited, the region as a whole held significance related to navigation, seasonal movement, and resource use. Much of this knowledge was disrupted by colonization, leaving gaps in the cultural record. In modern times, Lake Hillier has become best known through aerial photography. From above, the contrast between the pink lake, white sand, green forest, and deep blue ocean is striking. The image looks artificial, as if colors were exaggerated or digitally altered. Yet photographs taken decades apart show the same palette, unchanged. Access to the lake is strictly controlled. There are no roads, no viewing platforms, and no facilities. Most people who see Lake Hillier do so from the air, via scenic flights. Landing on the island requires permits, and direct contact with the lake is discouraged to protect its fragile ecosystem. This lack of physical access has contributed to the lake's mystique. It exists largely as an image, something observed rather than experienced. Few have stood at its edge. Fewer still have studied it closely over long periods. When water from Lake Hillier is collected and placed in a container, it remains pink. This detail is often cited because it rules out optical illusions caused by reflection or depth. The color is intrinsic to the water itself, not merely a surface effect. Despite its striking appearance, the lake is not considered toxic. The microorganisms present are adapted to extreme salinity, but they are not known to pose a direct hazard to humans. However, the salt concentration is high enough to make swimming impractical and potentially uncomfortable. From an environmental perspective, Lake Hillier represents a rare and stable microbial ecosystem. Such systems are valuable for understanding extremophiles, organisms that survive in conditions lethal to most life. Studying them can inform research into early life on Earth and the potential for life in extreme environments elsewhere in the solar system. Astrobiologists are particularly interested in saline and hypersaline lakes because similar chemical conditions may have existed on Mars when liquid water was present. Pigment-producing microbes could leave detectable signatures, offering clues for future exploration. Lake Hillier also raises questions about conservation. Climate change could alter rainfall patterns, evaporation rates, or groundwater chemistry, potentially disrupting the balance that maintains the lake's color. While its isolation offers some protection, it also means that any changes may go unnoticed until they become significant. So far, the lake appears unchanged. Historical records, photographs, and satellite imagery suggest remarkable consistency over decades. This stability makes it both reassuring and concerning. It suggests resilience, but also dependence on conditions that may not remain constant indefinitely. The surrounding ocean plays a quiet role in the lake's story. The Southern Ocean is one of the most powerful and cold bodies of water on the planet. Storms batter the coastline, shaping cliffs and beaches. Yet the lake remains calm, sheltered behind its barrier, insulated from direct wave action. This contrast, violent ocean beside placid pink lake, adds to the sense of unreality. Two systems exist side by side, interacting subtly but behaving very differently. At sunrise, the lake's color appears soft and muted, almost pastel. By midday, under strong sunlight, the pink intensifies. At sunset, the color deepens slightly, reflecting warm tones from the sky. Yet, it never turns blue or gray. It remains pink, regardless of light. This consistency challenges how people expect natural color to behave. In most landscapes, color shifts dramatically with time and weather. Lake Hillier resists that variability, reinforcing the impression that it is somehow artificial. But it is not. No dyes, no chemicals, no human intervention created this lake. Its color emerges from processes operating quietly over long periods, driven by life too small to see and chemistry too subtle to notice without instruments. Lake Hillier does not erupt, flow, or vanish. It does not threaten or overwhelm. Its impact is psychological rather than physical. It unsettles by contradiction, by being calm when it looks impossible, by remaining unchanged when change is expected. In a world where many natural wonders rely on scale or motion, Lake Hillier relies on persistence. It does one thing, continuously, without variation. It stays pink. That simplicity is deceptive. Beneath the surface lies a complex system of microbial life, chemical balance, and environmental isolation. Disrupt any part of it, and the color may fade or disappear. For now, it remains intact, quietly occupying its basin on a remote island, largely untouched and lightly understood. Lake Hillier does not ask to be solved. It exists as evidence that nature does not always provide clear answers. Sometimes it presents a result without explanation, a fact without narrative, a pink lake beside a blue ocean, a stable color in a changing world. a reminder that the Earth still contains places where certainty dissolves and observation must be enough. On Middle Island, far from cities and roads, Lake Hillier remains as it has for generations, bright, silent, and unresolved, holding its color against time and refusing to explain itself fully. The mountains painted by time. In northwestern China, along the ancient corridor that once carried caravans across deserts and mountains, there's a landscape that looks deliberately colored, as if the earth itself were layered by hand. Ridges ripple across the horizon in bands of red, yellow, green, and gray. Slopes curve and fold like fabric. Lines run with precision across hillsides, tracing patterns that appear too orderly to be natural. This is Zhangye, one of the most visually striking geological formations on the planet, and one of the clearest examples of how time, pressure, and erosion can transform simple materials into something extraordinary. Zhangye lies in Gansu province, near the city of Zhangye, on the northern edge of the Qilian Mountains. The region sits at the intersection of deserts, plateaus, and mountain ranges, shaped by long-term tectonic uplift and arid climate. What makes Zhangye unique is not a single mountain or peak, but an entire system of layered rock exposed across rolling terrain. The colors that define the landscape are real, not the result of vegetation or surface staining. They are embedded within the rock itself. Each band represents a different period of sediment deposition, compressed and tilted over immense spans of time. What appears vibrant and sudden today is the product of processes that began tens of millions of years ago. The story of Zhangye starts during the Mesozoic era, when this region lay beneath the shallow seas, rivers, and floodplains. Over time, layers of sand, silt, clay, and mineral-rich sediments were deposited horizontally, one on top of another. Iron, copper, and other trace elements were incorporated into these sediments, subtly altering their color. Under pressure, these layers hardened into sandstone and conglomerate rock. For millions of years, they remained buried, largely unchanged. The transformation into today's landscape required two additional forces: tectonic uplift and erosion. As the Indian tectonic plate collided with the Eurasian plate, the crust of Asia thickened and rose. This process, which also formed the Himalayas, affected regions far beyond the immediate collision zone. The land around Zhangye slowly lifted, tilting and deforming the once horizontal sedimentary layers. What had been flat became angled. What had been buried began to rise toward the surface. Once exposed, erosion took over. Wind, rain, and temperature fluctuations began carving the rock. Softer layers wore away faster than harder ones. Water followed fractures and weaknesses, cutting channels and valleys. Over time, the layered structure became visible, and the colors emerged in long, sweeping bands. The arid climate of Gansu played a crucial role in preserving the colors. In wetter environments, vegetation and soil would obscure the rock. Heavy rainfall could blur boundaries and promote chemical weathering that dulls color. Here, limited rainfall and sparse plant life allowed the exposed layers to remain clear and sharply defined. The result is a landscape often described as rainbow mountains, though the term simplifies what is actually a complex palette. Reds and oranges dominate, derived largely from iron oxidation. Yellows and browns reflect variations in mineral content and grain size. Greens and grays emerge where chemical composition differs, or where oxidation was limited. The colors follow the structure of the rock, tracing its folds and angles with remarkable clarity. Zhangye is part of a broader category known as Dangxia landforms, a term used in China to describe landscapes formed from red-colored sandstones and conglomerates shaped by erosion. Dangxia formations exist in other parts of the country, but Zhangyes are distinct for their scale and color contrast. What sets this region apart is not only the intensity of the colors, but the way they are arranged. Bands run parallel for long distances, maintaining consistency even as hills rise and fall. In some places, the layers bend sharply, revealing the force that tilted them. In others, they appear smooth and continuous, emphasizing the slow, patient nature of geological change. From ground level, the formations feel massive and enclosing. Ridges block the view, and color dominates the field of vision. From elevated viewpoints, the true scale becomes apparent. The bands stretch across entire hillsides, repeating over kilometers. The land looks less like a series of individual mountains and more like a single surface folded repeatedly. Despite its dramatic appearance, Zhangye Dangxia remained relatively unknown outside China until recent decades. Local populations were familiar with the terrain, but it was not widely promoted or studied internationally. This changed as infrastructure improved and images of the landscape began circulating globally. In 2010, Zhangye Dangxia was designated a UNESCO World Heritage Site as part of the China Dangxia Landform Group. This recognition brought increased attention, tourism, and conservation efforts. Viewing platforms and boardwalks were constructed to manage foot traffic and reduce erosion caused by visitors. These measures were necessary. The rock surfaces, while ancient, are fragile when exposed. Walking directly on the formations can damage the thin crust and accelerate erosion. Human presence also introduces dust, oils, and moisture that can alter surface chemistry. Controlled access helps preserve the clarity of the layers. The park's layout emphasizes observation rather than exploration. Visitors move between designated viewpoints, each offering a different perspective on the landscape. At sunrise and sunset, the colors appear more saturated, shadows deepen, and the contours of the land become more pronounced. Midday light flattens the scene slightly, but reveals finer details and texture. Weather plays a subtle role in how Zhangye Dangxia is perceived. After rain, colors intensify as moisture darkens the rock, increasing contrast. In dry conditions, the surface appears lighter and more matte. Seasonal changes affect temperature and light, but the overall appearance remains consistent. Unlike volcanic landscapes shaped by sudden events, Zhangye Dangxia represents gradual transformation. There are no craters, no lava flows, no active faults visible at the surface. The drama lies in exposure rather than eruption. Time is the dominant force here, not violence. The region's location along the ancient Silk Road adds a human dimension to the landscape. Zhangye, historically known as Ganzhou, was an important stop for traders, monks, and emissaries moving between east and west. While the Dangxia formations themselves were not central to trade, they formed part of the broader environment through which caravans traveled. For centuries, these mountains existed as background rather than destination. They were passed by, not studied. Their transformation into a globally recognized natural wonder reflects changing attitudes toward landscape and geology. Scientifically, Zhangye Dangxia offers valuable insights into sedimentary processes, tectonic deformation, and erosion in arid environments. The clarity of the layers allows geologists to trace deposition sequences and deformation patterns with unusual precision. Each band represents a distinct chapter in the region's geological history. The formations also serve as a visual reminder of scale. What appears colorful and decorative is, in fact, the exposed record of millions of years of accumulation and movement. The human eye interprets color emotionally, but the underlying story is one of pressure, chemistry, and time. Culturally, the landscape has inspired comparisons to paintings, textiles, and abstract art. These analogies reflect how difficult it is to process such formations without reference to human creativity. Yet the land predates art, language, and culture by orders of magnitude. There are no ancient ruins embedded in the Dangxia Hills, no carved temples or monuments. Human presence is recent and superficial. The land does not bear marks of civilization, only of geology. At night, the area grows quiet. Artificial lighting is limited, and the surrounding region is sparsely populated. The sky opens wide, stars visible above dark silhouettes of layered hills. Without color, the land becomes shape and shadow, its complexity hidden until light returns. The Dangxia formations are not static. Erosion continues, slowly altering ridges and slopes. Over long periods, colors will fade as layers wear away and new surfaces are exposed. The landscape seen today is temporary on a geological scale, even if it feels permanent to human observers. Climate change may influence erosion patterns in the future. Changes in rainfall intensity could accelerate surface wear or alter drainage. Increased tourism, if not carefully managed, could introduce additional stress. Preservation depends on maintaining balance between access and protection. For visitors, Zhangye Dangxia often produces a sense of disbelief, similar to that inspired by other extreme landscapes. The mind struggles to reconcile the precision of the bands with natural randomness. The result feels intentional, as if the land were designed to be seen from above. But there is no design, only accumulation. No brush, only sediment. No palette, only minerals responding to oxygen, pressure, and time. Zhangye Dangxia does not erupt, flow, or vanish. It reveals. It exposes what was once hidden and holds it in place long enough to be witnessed. Its colors are not fleeting effects of light or water, but structural features embedded deep within the Earth's crust. In a world where natural wonders are often defined by movement, waterfalls, waves, storms, this landscape stands apart. Its power comes from stillness, from layers that do not move, but remember. Each stripe across the hills is a record of a former surface, a former environment, a former time. Together, they form a visible archive, stacked and tilted, waiting to be read. In Gansu province, where deserts meet mountains and history crosses geology, the land wears its past openly. Zhangye Dangxia is not a miracle of color. It is a consequence of patience. And in those bands of stone stretched across the hills, the earth shows what happens when time is allowed to work without interruption, quietly, relentlessly, and in full view. As this journey ends, these places remain, shaped by forces far older than us and still at work today. They remind us that the earth is never finished, only changing. Thank you for watching Unearthed Secrets. Until next time, keep looking closer beneath your feet.